There is another way, of course, of solving quadratics, and that is by completing the square. So you get something like this. Now, yes, I know it can factorise. Let's pretend I can't work out the numbers. Ah, damn. Okay, completing the square. The first thing we do is move the constant number to the other side. So we get x squared plus 6x equals 7. Then add half the coefficient of x squared. Now that pause is important, because it's not half the coefficient of x squared, but half the coefficient of x squared. Now in this case, the coefficient of x is 6. Half of that's 3. 3 squared is what I'm adding to both sides. Why do we do that? Because have a look on the left-hand side. I've now created a perfect square. Hence the name of the method. We have completed the square. All right, so let's say the left-hand side is now a perfect square. X plus 3 squared is 16. Well, that means x plus 3 is plus or minus 4. We can move the 3 over, and in this case we can work it out. So we get negative 3 minus 4, that's negative 7. Negative 3 plus 4, and that's positive 1. So that idea of completing the square comes in very, very handy for certain things, such as the quadratic formula. This is where it comes from. The general equation of a quadratic, ax squared plus bx plus c is equal to 0. I'm going to complete the square. We tend to prefer to complete the square when the coefficient of x squared is 1. So the first thing I do is divide everything by a. Move the constant to the other side. So we now get minus c on a. Add half the coefficient of x squared. Well, the coefficient of x in this case is b on a. So half the coefficient of x is b on 2a. Square it. B squared on 4a squared is what we have added. So on the left-hand side, complete the square. We get x plus b on 2a all squared. The right-hand side, let's tidy up that fraction. B squared minus 4ac, starting to look familiar, over 4a squared. So therefore, x plus b on 2a is equal to plus or minus the square root of b squared minus 4ac over 2a. Move the b on 2a over, and there's what we recognise to be the quadratic formula. That's where it comes from. And so rather than having to complete the square every time, now that we've created the formula, that's why we use the quadratic formula. That's where it comes from. I'm going to do another one, but I'm going to do it a little bit differently. X squared minus 6x plus 6 is equal to 0. I'm going to say, well, I know that when I complete the square on this one, I would end up with x and then half the coefficient of x. Well, half the coefficient of x here is 3, or negative 3 rather. So I know I would have ended up with x minus 3 squared, but if I was to expand that out, I'm not going to get 6. I'll get 9. I can't just change the equation. So how do I get from 9 to 6? I subtract 3. Now I can say it because I've got the difference of two squares. So I can say, oh, well, it's x minus 3 plus the square root of 3, or x minus 3 minus the square root of 3. So therefore, x is 3 minus root 3, or 3 plus root 3. So that's a different way of using the completing the square method. Okay. Wow, that should be enough to keep us busy.